Okay, so I'm live now. Yep. So we'll just wait for a few people to join. So before starting with anything, I'll just like to introduce myself. My name is Sanjeev Das, and I'm going to teach you today's topic about structure of atoms. And in that, we are going to cover amazing and interesting topics. But before that, if you're new to this channel, then please do subscribe to our channel and do press the bell icon so that you never miss an update from us. Also, we have a lot of courses on our website. The video is not clear. Okay, Vemi, ready? Let me just check with the internet. I just hope it should be clear right now. Just let me know in the chat box if it's proper or not. Yep. I'll just check that thing. Till then, I'll just display the slide actually. Yeah. So this one's the slide. Okay. Okay, now I guess it should be clear, guys. Do check it. And of course, we are going to start with our today's topic, that is structure of atoms. And in that, we are going to cover what was J.J. Thomson's atomic model, and what is Rutherford's atomic model, and what is Neil Bohr's atomic model. So these are the topics which we are going to cover today. These are the topics which we are going to cover today. Hello, Vemi Reddy. I know you. Bharani. Yeah. So Bharani, hello, hi. Murali. Yeah. So these are the few interesting topic which we are going to cover today. So before starting with that, let me just once again say that if you haven't subscribed to our channel, then do subscribe and don't forget to press the bell icon so that you never miss an update from us. Also, we have a lot of courses on science and math on our website. Actually, we have a website of our own, and that is www.letstute.com. So you can just check it in the description or box, or in few seconds you'll just find it in the chat box also. So you can just go through it and find some amazing videos related to that. Okay, so let's, without wasting, thank you so much for subscribing us. Okay, so without wasting any time, let's quickly start with the today's topic and try to understand what were the things which we covered last time. So the first thing which we understood, so the first thing which we understood was that a atom is electrically neutral. This was a particular thing which was for a long time the scientists used to believe this thing, that atoms are electrically neutral and there are no charges present in it. And we went through examples in which we saw how different scientists had proved the charges which are present in the atom. The first one was electron, which was discovered by J.J. Thomson, and the second one was proton, which was discovered by Goldstone. So electron is negatively charged and protons are positively charged. They are equal in magnitude but opposite in size. But of course, their weights are different. They differ in the weights. So the proton is actually 2000 times heavier than electrons. These were the basic things which we had covered in the last lecture. And if you have missed the last lecture, you can just go through our videos, check them, and understand whatever I'm trying to say. Okay. Yep. In the last session, very good, Vemi Reddy. In the last session, we discussed about two subatomic particles, that is electrons and protons. Today, we are going to discuss. So basically, we got to know that atom is not neutral. There are subatomic particles inside the atom. So we should know what is the structure of atom. So there was a race between the scientists. There was a race between the scientists that what is the structure of atom. Yes, proton was discovered by Goldstone. Very good. Yes. and electron was discovered by J.J. Thomson. So these were the two things which were discovered by different scientists, and there was a need for structure of atom, like what is the structure of atom, or what are the positions of electron and proton inside the atom. So there was a race between many scientists. So the first scientist, J.J. Thomson, gave a model. So this is J.J. Thomson. He was the first one to give a atomic model. What is an atomic model? It simply says an atomic model is simply which defines what is the structure of atom. So J.J. Thomson was the first one to define what is to give the atomic model. So, and who is J.J. Thomson? What are his achievements? So J.J. Thomson is a British physicist, and he was awarded with Nobel Prize in Physics in 1906 for his work of discovery of electrons. So he was the one who discovered electrons, and he got a Nobel Prize because of it in 1906. Okay. So now let us try to understand what was the model which J.J. Thomson gave us. So the J.J. Thomson gave us a model in which there was a whole sphere, and it was considered as a proton, and there were many electrons embedded inside it. So if you try to imagine the structure, whatever it's happening, so there's a whole proton, a solid proton, and inside that there are many electrons embedded inside it. So these all black dots are actually electrons, and the whole white color structure, or the whole white color ball, is proton. Okay, so this was the atomic structure given by J.J. Thomson. If we try to understand it with the signs, so the negative signs are actually of electrons, and the whole sphere is of proton. This shape was actually compared with two things. Now try to understand this story. This structure was actually compared with two things. The first thing is a pudding, a Christmas pudding, in which you can have dry fruits or plums actually. So a plum cake or a pudding in which there are dry fruits. So this whole atom is like a pudding where the dry fruits or the electrons are embedded inside it. So let us try to find out what did J.J. Thomson propose. So these were the two things which he proposed, that the atom consists of positively charged sphere and the electrons are embedded inside it. As we can see in the diagram, the electrons are embedded inside the proton, and proton is nothing but a sphere, a solid sphere. Okay. And the next thing was, he was successful to prove that, or maybe he was able to say that the atom is electrically neutral. Why is it electrically neutral? Because there are electrons as well as protons, so both the charges are actually cancelling each other. So he was very successful in proving that the atom is electrically neutral, because he had shown that there are negative particles as well as positive particles, or maybe the charges which are equal in magnitude. Okay, so this was the atomic structure which was given by J.J. Thomson. You can just draw it in your book, or maybe try to understand this diagram by looking at it. Okay, so the whole white color sphere is actually a proton, and the electrons are embedded inside it. The whole atom is electrically neutral because electrons and protons are opposite in charges, and they have equal magnitude. So it's cancelling each other and making it neutral. Okay, so now what was the need, or maybe why did the structure of atom change? Because there were many scientists actually, or maybe a scientist who had performed an experiment, and J.J. Thomson was not able to justify his results. Okay, so who was the scientist? So let us try to understand Rutherford's experiment. So who's Rutherford actually? So Ernest Rutherford, he was a well-known scientist actually. He's known as father of nuclear physics. So he's known as father of nuclear physics, and he has worked on radioactivity and discovery of nucleus of atoms, and with his gold foil experiment. And his gold foil experiment is actually very famous. So we are going to learn, or maybe we are going to understand what was his experiment, the gold foil experiment or the alpha particle scattering experiment, which can come in your exams, and it is very important. Okay, so he got a Nobel Prize in chemistry. Actually, he got a Nobel Prize in chemistry in 1908. So in 1906, J.J. Thomson was the one who got a Nobel Prize for discovery of electrons. In 1808, in 1908, Rutherford was the one to get a Nobel Prize because of his gold foil experiment. So let us try to understand what was the gold foil experiment about. So suppose this is a gold foil actually. So this is nothing a gold foil. So first question which should come in your mind is why did Rutherford choose gold foil? Why did Rutherford choose gold foil? So you can just answer this question in comment section, or maybe even I'm going to answer this question. So this is actually a gold foil, and why did Rutherford choose gold foil? This is the question. For his experiment, why did he choose gold foil? He could have chosen any other foil actually, maybe a copper foil, or maybe any other foil, any other metal. But why did he choose gold? To see clarity, no, actually, yeah, but the main reason why did he choose gold was gold is a metal which is a good we can it can be drawn into very thin sheet actually. So very thin sheet means the malleability property. So metals have many properties. So malleability is one of them, that is drawn into sheets. Okay, so this can be drawn into a very thin sheet, and the thinnest sheet which was possible was about 1,000 atoms. And 1,000 atoms, don't get it wrong, 1,000 atoms are actually very thin. It means only 1,000 atoms were. It was only 1,000 atom thick. So that means it's very thin. So he chose gold foil because it can be drawn into a very thin sheet. Okay, and the thin sheet was about 1,000 atoms thick. He took alpha particle and he bombarded the alpha particles on the gold foil. Now, something about the alpha particle. The alpha particle are doubly charged helium ion. And now, what do we mean by doubly charged helium ion? It simply means it's positive. Okay, and the atomic mass of the alpha particle was 4u, or maybe 4 unified mass, which we have learned actually. What are u, or what is the unit of atomic mass, or what is the mass, atomic mass ka unit? So 4u was the atomic mass of these alpha particles. He took these alpha particles and he bombarded, or maybe he made them fall on the gold foil. And let's try to understand what was the whole experiment about. So in this experiment, when he bombarded, or maybe when he made the alpha particle fall on the gold foil, or maybe the thin gold foil, he noticed that most of the fast moving alpha particle passed straight through the gold foil. Okay, most of the alpha particle which were there, it passed straight through the gold foil, as you can see in this also. Wait, let me just show. So here you can see that most of the alpha particles are passing straight from the gold foil, but only some of the alpha particles are deflected by foil by a small angle. Now, what do we mean by a small angle? So these angles are actually very small angles. Okay, so these are very small angles, and these are a a large amount of angles. So these two are large amount of angles, and surprisingly, only one out of 12,000 particles apparently rebounded. That means some of the alpha particle, that is a very less number of alpha particle, used to rebound back, like it used to rebound back towards the source of the alpha particle. Okay, my voice is not clear. I just hope it's now clear. Okay, so the main thing, or maybe a main question was in front of Rutherford that these alpha particles were actually positively charged. Now, why did he use helium ions, positively helium charged ions? We will try to understand that in the further slides actually. But before that, a question is here that this was about 4U, that is 4 unified mass, and or maybe the electrons, or maybe the protons inside atom the protons inside the atom are actually very very lighter than these doubly charged alpha particles, or maybe the alpha particles. So if you try to imagine, the alpha particles were really very heavy. The alpha particles were really very heavy, but in fact but alpha particles were really very heavy, but the alpha particles were very heavy and the protons were actually light in weight, but still the alpha particles rebounded back. Why did that happen? And the whole experiment was so incredible that Rutherford stated, the words of the Rutherford were, this result was almost as incredible as if you fire a 15-inch shell at a piece of a tissue paper, it comes and hits you back, comes back and hits you. So that simply means this is nothing but a tissue paper, and this is a shell, a 15-inch shell, and we are just firing the 15-inch shell, and it's hitting the tissue paper and it's rebounding back. That's impossible, right? Similarly, in case of the alpha particles were really very heavy in compared to the protons. So when it struck the protons, it didn't take the protons with itself, it rebounded back. So it was very incredible, or maybe insane kind of result. So to understand more about this experiment, or what was the conclusion that he drawed from the experiment, what was the conclusion that he drawed from the experiment? To understand that, let us try to understand an example. So suppose if you have two walls, actually if you have a wall and if you have a fence, so wall is actually fully covered and fence has hole inside it, okay? And if you have a blindfolded child and if you give him 10 stones in his hand, okay, so the task of the child is to throw stones at the wall, or maybe on the fence. So when the task was given to the kid to throw the 10 stones on the wall, he could hear that every stone used to hit the wall, okay? So whenever you hit a stone on a wall, every stone will hit the wall. So if you tell the kid to throw the stone 10 times, the stone will hit the wall 10 times. But if you tell the kid to throw the same number of stones on a fence, maybe you could hear only 5 number of times the stone hitting the fence, because most of the stone may pass through the fence because there are hole inside the fence. So fence has hole inside it, so most of the stones used to pass through the fence and only few number of stones used to hit the fence. So the same experiment, if you compare with J.J. Thomson's model and Rutherford's experiment, the wall is like J.J. Thomson's atomic model. So what did J.J. Thomson say? That the atom, the proton is actually is like a sphere, like a solid sphere. The whole proton is like a solid sphere. So you can compare it to a wall. But now, after the conclusion or the experiment which was performed by Rutherford, the experiment or the results were like these pens. That is, most of the stones or most of the alpha particles used to pass through the atoms and only few used to hit the protons actually. So what was the conclusion made by Rutherford? So most of the space inside the atom is empty because most of the alpha particles pass through the gold foil without getting deflected. So most of the alpha particles used to pass directly through the gold foil. Very few particles were deflected from their path, indicating that the positive charge of the atom occupied very little space. So if you try to understand this structure, there's a whole atom, and the protons or the positively charged particles are actually very small, which is occupying very little space. And because it's um, occupying very little space, it's deflecting at a small angles. Only small angles. They are deflecting at small angles. Very small fraction of alpha particle were deflected by 180 degree. Okay, so this is not 1800, it's 180 degree. It's a typo over here. So 180 degree, indicating that the concentrated is very small volume within an atom. So the concentration of the positively charged particle or the mass of the gold atom is actually concentrated in a small volume. That is, the whole mass is actually concentrated on the proton. Okay, so let's try to understand this whole experiment once again, because it's quite a heavy experiment, but it's actually very simple. So what did Rutherford did? Rutherford took a gold foil and he used the alpha particles to bombard it on the gold foil. Now the alpha particles actually are positively charged. So what happens when positively charged particles comes near proton? So protons are also positively charged. So what happens? Either it passes through the gold foil because most of the particles are empty space, or maybe there's no particles present inside the atom. Most of the space is actually empty, so it directly passes through it. And some of the particles, the alpha particles, it deflects because both are positive, so it repels. It kind of repels. Only few alpha particle rebounds back because the volume of proton is very small. Okay, so I hope you got this thing when we ready. Why helium, or maybe helium ion, or maybe why alpha particles? Because they are positively charged, and we are supposed to use positively charged particles to bombard it on the gold foil, so that when the positively charged particle hits the positively charged protons, it either deflects in a small angle or rebounds back. But what did we observe? We observed that most of the alpha particles used to pass directly through the gold foil because most of the space inside the atom is empty. So these were the conclusions which was made by Rutherford, and then he proposed, or he gave an atomic model. So how did the atomic model given by Rutherford look? So this was the atomic structure which was given by Rutherford. So this is an atom. This small particle is proton. The smallest the concentration is actually called as nucleus, and inside that there are protons. These electrons are actually on the outer circle of the atom. So it's just revolving around the atom. So these are electrons. So now Rutherford said these things like protons, the positively charged particles, the positively charged particles are actually concentrated in the atom, and the negatively charged electrons are actually revolving around the nucleus. So this is a nucleus and the electrons are actually revolving around it. Now, a question was arised at that time that if the electrons are rotating or revolving around the proton or maybe the nucleus, it would radiate some kind of energy because a moving body emits energy. So these electrons may emit some kind of energy or some kind of charge. So it used to emit some kind of energy, and ultimately when it starts radiating energy, it would lose all its energy and it will fall ultimately to the nucleus. So I'll try to understand this concept once again. If the electrons are actually revolving around the nucleus, if the electrons are actually revolving around the nucleus, it would radiate energy, and if it's radiating energy, it would lose its energy, and while it is losing its energy, it would ultimately fall into the nucleus, and this will make an atom unstable because all the electrons will fall inside the nucleus, and this will make atoms really unstable. Vemi Reddy, I didn't get your question actually. Can you just frame your question once again so that I can answer you? What is your question actually? So I hope you got this thing actually. So if electrons are negative and it's radiating energy while revolving around the nucleus, it will radiate energy. And while it is radiating energy, ultimately it would fall into the nucleus. Okay. So what was the solution or what was the explanation? Rutherford wasn't able to explain it. So this was a major drawback of Rutherford's model. This is the atomic model which is proposed by Rutherford. Of course, it is fantastic. It explains that there is space inside the atom. Most of the space is empty inside the atom, and only a small amount is occupied by protons in the center. And most of the mass is concentrated inside the nucleus. The whole mass is concentrated inside the nucleus. Okay, so this was the atomic structure proposed by Rutherford, but of course he wasn't able to explain, or there were some drawbacks. So who was the scientist who covered him? So Neil Bohr was the one who also gave an atomic model to justify the reason why didn't the atoms actually fall inside the nucleus. So let us try to understand who Neil Bohr was. So Neil Bohr was the one who got a Nobel Prize for his work on structure of atoms, and he has contributed a lot in structure of atoms. So in 1922 he was the one to receive a Nobel Prize for structure of atom. Okay, so let's try to understand what was the structure of atom given by Neil Bohr. So Neil Bohr said many simple things. He said that only certain specific orbit known as discrete orbit of electrons are allowed inside the atom. So if there is an atom, there will be only discrete orbits. That is, there may be only one orbit, or maybe two orbits, or maybe three orbits. The number of orbits which are required for the particular atom, only that many number of orbits will be present inside the atom. Not more than that, not less than that. Okay, while revolving in this discrete orbits. So try to understand this thing. He said while revolving around in this discrete orbits, the electrons do not radiate energy. So what was the theory which we studied, that if an electron is revolving around any nucleus, or maybe any body, whichever is revolving around a certain particular object, it would radiate energy. And if electrons are radiating energy, it would ultimately fall into the nucleus. But why electrons were not radiating energy, or maybe why electrons were not falling into the nucleus? It was because when the electrons are revolving around the discrete orbits, or maybe the separate orbits, so each electron, or maybe every electron every electrons have their specific orbits to revolve. So in the first orbit there will be 2 electrons, in the second orbit there will be 8 electrons. So these are the number of electrons which are possible in these kind of orbits. So only specific number of electrons, or maybe the specific electron will revolve in that discrete orbit. And while revolving in the discrete orbit, it won't radiate energy. And this was the model which Neil Bohr suggested. So this was the model. So Rutherford simply said that electrons are around the nucleus, but he didn't say that it is present inside a specific orbit or something. Neil Bohr was the one to say that electrons are present in discrete orbits. These orbits are known as energy levels. Okay, so try to understand this. Okay, okay, helium means, okay, helium is a name of an element. So if you try to look at a periodic table, you will find that there is a element known as helium, and its atomic number is 2. Okay, so you'll find it in the periodic table. You can just go through it. We can't see atoms with our naked eye. Then how they have seen it? Okay, so if, okay, I got your question when we ready. You're asking how did they see that it is getting deflected, or in which position it is getting deflected. Of course, I'll explain you that thing once again. My mistake, of course. I didn't explain that particular thing. So as you can see, there is a screen. There is a circular fluorescent screen, If you remember the last experiment in which there were cathode rays and anode rays, and it was made fall on a particular screen. It was made on a fall. It was made fall on a particular or maybe a special screen, which would light up, which would glow on every stripe. Similarly, in this case also, there was a circular fluorescent screen present around this gold foil. And whenever the alpha particle used to deflect from the gold foil or maybe used to pass straight through the gold foil, you can see that there are certain marks present over here. And based on that marks, scientists used to identify that whether the alpha particle is deflected or maybe it has passed straight through the gold foil. I hope your doubt is cleared, Vemirati. Okay, so guys, if you have any doubt related to these topics, you can ask me. Okay, I'll just answer the questions. So we were over here and we were saying that that boron, Niels Bohr actually. Niels Bohr. So this was the atomic structure which was given by Niels Bohr. So these orbits are actually energy levels. So these are known as energy levels, and these are represented. These orbits are represented, or these shells are represented as KLMNOP or maybe any other name. So these are the names which are given to it. So KLMN, or maybe you can even number the number of shells. So this is the first shell, this is the second shell, this is the third shell, this is the fourth shell. So this is a way of saying or maybe a representation for particular number of orbits. So this was the whole structure which was given by Niels Bohr. So there is discrete orbit. As you can see, there are discrete orbits and electrons are revolving around the nucleus. So electrons are revolving around the nucleus or maybe the proton, and while they are revolving in discrete orbits, in separate orbits, it's not radiating energy. Okay, so I hope this thing is very very clear to you guys. Before saying anything, I will just like to say that if you're new to this channel, then please do subscribe to our channel. You can find a small subscribe button, and beside that you'll find a small bell icon which you can press, and so that you never miss an update from us. Also, if you want some courses based on math or maybe on science, you can find it on our website. We have a website that is www.letstute.com. In that you can find some amazing videos related to math as well as science. So before concluding, let me just go through everything whatever we have completed till now. So structure of atoms, we used to understand that atoms are actually neutral, but after the discovery of charged particles, we found that there are certain charge inside atoms. So what was the structure or what was the position of these charges inside the atom? So J.J. Thomson was the first one to give a proper atomic structure, or he was the first one to give an atomic structure, and even he received a Nobel Prize because of discovery of electron. So this is the structure which was proposed by J.J. Thomson, in which he said that the proton is nothing but a sphere. Atom consists of protons inside which electrons are embedded inside it. So you can compare this whole structure to a pudding or maybe watermelon. So that if you want to compare it to a watermelon, you can just consider it as the red color part, which is the edible part. You can consider it as proton, and the seeds inside the watermelon are like electrons. So you can compare it to watermelon, or maybe you can compare it to Christmas pudding. Okay. And next, after the structure, he because J.J. Thomson wasn't able to explain few of the experimental results, like because J.J. Thomson proved a very interesting thing, that most of the alpha particle passed straight through the gold foil. So what was the gold foil experiment, or maybe what was the scattering experiment which was performed by Rutherford, Ernest Rutherford? So there was there was 1,000 atom thick gold foil. He had alpha particle and he made the alpha particle fall on the gold foil. These alpha particles were actually doubly charged helium ions, which are positive charge, and the mass or the atomic mass of these charge were 4u. So this was the structure which was this is the whole experiment which is there. So this is a screen through which we can see what is the deflection of the alpha particles. So what was the conclusion that he found? That most of the fast moving alpha particles passed straight through it. Only some of them had a small angle, and only one out of 12,000 particles appeared to rebound back. So only a very small number of particles used to rebound back. So what was the conclusion um, made by Ernest Rutherford? So he said that most of the space inside the atom is actually very empty. So it's empty, and therefore alpha particle used to pass straight through it. Because it's empty, most of this alpha particle used to pass straight through it. Okay, very few particles were deflected from their path, indicating that positive charge atom occupies very little space. Because a very small number of alpha particles used to deflect from their position, that simply means a very small amount is actually positively charged particles inside the atom, and it occupies very little space. So if you try to compare this, and a very small number of particles, or maybe a very small number of particles used to deflect back, that is in 180-degree, indicating that the positively charged particle has the whole mass of the gold atom. That is, the mass is actually concentrated inside this small nucleus. Okay, so this was the structure which was given by Ernest Rutherford. But of course, if he even said that the electrons are actually revolving around the nucleus, but he couldn't explain if the electrons are revolving around the nucleus, it would radiate some kind of energy. And if it's radiating energy, it would ultimately lose its energy and fall into the nucleus. But that wasn't happening, because if that happens, atom will become very unstable. But we don't see that happening, because atoms are not really stable. Atoms are actually very stable. So it doesn't happen that electrons fall into the nucleus. So why doesn't that happen? So Neil Bohr was the one to suggest, or maybe he was the one to find out, that the electrons are actually revolving in discrete orbit. What are these discrete orbit? These discrete orbit have a special characteristics, that if electrons are revolving in this discrete orbits, it won't radiate energy. So if electron is revolving in this orbit, it won't radiate energy. These shells, or maybe these orbits, are known as energy levels. These orbits are known as energy levels, and for representation purpose, you can name the first shell as K, the second shell as L, the third shell as M, and so on. Or maybe you can even number them, that is 1, 2, 3, 4, and so on. So this was all about Ernest, this was all about Niels Bohr atomic model. Till now we saw three atomic models. Okay guys, so I hope this thing is very clear to you guys, how did everything worked actually. So guys, if you have any doubt, you can just post it in the comment section, so that we can address that doubt. I'll just place the first screen actually. So yeah, so this is the thing which we studied today. That is J.J. Thomson, Rutherford's atomic model, and Niels Bohr atomic model. So I'll just like to say once again, so if you're new to this channel, and if you haven't subscribed to our channel, then do subscribe, and don't forget to press the small bell icon, so that you never miss an update from us. Also, we have a lot of courses on our website, courses related to math, courses related to science. So the courses are actually very amazing, and we have amazing courses on our website. You can just check it on our website. Our website is www.letstute.com, and you can go and check it over there. The links are there in the description box, as well as in the comment sections. Okay, so you can just check it on that. I don't think so you guys have any doubts. So okay, so I'll just end this lecture. Okay, so before ending this, I'll just like to say once again, do subscribe to our channel and be tuned to get more live sessions, more amazing video content in our YouTube channel. Okay, so bye guys, catch you guys later. Okay, bye.